Hi, in this paper, we present graph-driven interaction sampling, a method that can generate realistic and diverse multi-person interactions by leveraging existing two-person motion diffusion models as motion priors. Instead of training a new model specific to multi-person interaction synthesis, our key insight is to spatially and temporally separate complex multi-person interactions into a graph structure of two-person interactions, which we name the Pairwise Interaction Graph. Here are some examples, and the bottom right is the Pairwise Interaction Graph of the scene. Each vertex corresponds to the motion of one character, and directed edges indicate conditional dependencies between motions. In recent years, many two-person diffusion models have been proposed. However, their pipeline cannot directly extend to multi-person scenario. Most of them are designed for a fixed number of people, and existing multi-person datasets are limited in scale and diversity, often featuring a relatively small number of subjects and covering only a narrow range of interaction types. To leverage rich two-person motion prior, our key insight is that multi-person interactions can be modeled using a graph. For example, a simple cyclic graph or a 2 versus 1 graph. Thus, we decompose the interaction into a composition of two-person interactions between graph neighbors, with each person's motion conditioned only on that of one other. Exactly the situation that two-person interaction models are already trained for. We can have many graphs with more than 10 characters. A classic team fight, a circle, a central pattern, or a very complex multi-person interaction. In addition, the graph can be time-varying, changing through the timeline, interacting with character 2 first, and then 3. However, when there are unconnected pairs in the graph, these two characters are very likely to collide because they don't follow the interaction rules from the pre-trained two-person model. To solve the problem, we propose interaction sampling optimization. We use proxemics loss to guide the sampling, pushing unconnected characters away from each other. We also introduce GLI loss to improve artifacts like penetration between pairs. Please see the paper for the details. Here we show a time-varying example, the red character fight with more and more enemies. We also allow different text between different condition pairs in the same graph. Here is a complicated fight example with time-varying graph and different texts among pairs. Here, we show a case of multi-reaction generation. The blue character is the clean motion condition, and we generate two different reactions for it. Next, we show some comparison results with the state-of-art multi-person interaction generation model. It demonstrates that our generated interactions have less interpenetration and align more closely with the two-person text prompts and are smoother. Then we show that our optimization step with GLI loss successfully reduced the artifacts in close interactions. Subsequently, we show the ablation study of our two optimization loss. As what we introduced just now, the proxemics loss plays a very important role in our graph-driven sampling process. GLI loss also plays a crucial role in reducing severe penetration in multi-person interactions, especially for very close interactions. Finally, we give some failure case of our methods, which illustrate some limitations of our approach. For highly dynamic motion with 5 more people, the circle graph sometimes causes heavy collision. And, for interactions without a suitable case in the two-person dataset, it will fail to generate high-quality multi-person interaction. Thank you very much for watching the video.